Hi, this is Math with Beth, and we are going to talk about limits today. This is going to be the intro to limits, and we're also going to talk about limits on a graph. So first I'm going to read the technical definition and then I'll explain it. So it says, for a function f of x and L, a real number, the limit as x approaches a of f of x equals L, if and only if the limit as x approaches a from the left of f of x equals the limit as x approaches a from the right of f of x equaling L. The limit of f of x does not exist if the left-hand or right-hand limit does not exist, or if they exist but are not the same. So that's a lot, but here is what that actually means. So I'm just going to kind of do one with the graph, and then I'll go back to that definition and see how that applies. So f of 2, most people are probably okay with, means looking on the graph, find where the x is 2 and find where that exists on the graph. Well, this is an odd graph where there's a hole here at 2, but there is an actual point down here. So that is where you're looking. So f of 2 would equal 1 because when x is 2, the y value is 1. Now, this notation is saying the limit as x approaches 2. So this is different than saying what is happening at 2. It's saying we're approaching 2, and this little negative up here means from the left side. So on the graph, it means go to where this graph is heading towards 2 and see what number it is approaching. So even though in real life, we know there's a hole here and it jumps down, if we just care about what number is being approached from the left, it is that open circle number, which is positive 3. So from the left, we are approaching 3 when we get to 2. This is saying, what is the limit as x approaches 2, but this time coming from the right side. So if we're coming from the right on the graph, it is still approaching that same open circle at 3. So it doesn't matter that these are different than the actual value at 2. Okay? So now if we just want to know what is the limit as x approaches 2, and I'm not specifying left or right, it means I have to look at both. So since we already know that from the left we're approaching 3, and from the right we're approaching 3, we can say 3. So that is what this definition is saying. It's saying the limit is a certain number L if that is the answer for when you're coming from the left, and it's the same answer when you're coming from the right. Then that is your final answer. So that is what we just saw. So now let's just look at a different one. So in this case, f of 2, I can't find anywhere on the graph at 2. So f of 2 actually does not exist. That's what D&E means, does not exist. But that doesn't mean the limit doesn't exist. So let's see. What would be the limit as we're approaching 2 from the left? Well, from the left, we're going to be going up and up and up forever, which means positive infinity. Now let's look where we're approaching 2 from the right side. Coming from the right towards 2, we are also going up forever, which means infinity. So again, since my answers match coming from the left and coming from the right, I can say that my answer is infinity. So sometimes you're going to be asked individually left and right, but if you're ever asked with no left or right, it means you still have to look from the left and the right because sometimes they're not going to match, and we'll see that in a second. There it is. Okay, so let's look at this example. So first, again, what would f of -1 be? So this has nothing to do with approaching. This has nothing to do with limits. It just means what is actually happening at -1. And again, I can't find the graph at all. So it does not exist. But for the limit at -1 coming from the left, so these negatives get a little confusing. So make sure you understand this negative means -1, but this little negative up here means we want to come from the left. So coming from the left, the graph heads down, down, down forever as we get closer to x equals -1. Now let's do the same thing, approach -1, but from the right side. Coming from this way, as we get closer to -1, we go up forever. So this time the answer is positive infinity. So now when they ask me the limit at -1, I already know that from the left and from the right, I got two different answers. So this time my limit does not exist at -1. Because in order to have a limit, it has to match the answer you would have gotten if you did it from the left and from the right. So now we're going to do the exact same thing, but with a table. So if instead of a graph, you just have a bunch of values on a table, here's how you could answer the same type of questions. So if they asked for the limit as x approaches +1 from the left. So first you would need x values that are getting closer and closer to +1, but coming from the left. So coming from smaller values heading towards 1. So that is what happens here. You now want to see what number the y value is approaching. And here it's pretty obvious that it's getting closer and closer to 4. So now let's look at a table showing us values getting closer to 1, but coming from the right. So coming from larger values of x and coming closer and closer to 1. What type of thing is happening with the y values? Well, it looks like they are getting closer and closer to -2. So if we were asked the limit as x approaches 1, we saw that we got different answers coming from the left and coming from the right. So this is an example, again, of one that doesn't exist that we found just by looking at a chart of values. Okay, one last one, and I think you'll get the gist of this. So g of 1 from the graph, be careful, there's an open circle there. So g of 1 has to be this one, which is -1. And now the limit as x approaches 1. It doesn't say from the left or right. So even though they didn't ask me, I technically need to do the left and right separately. So from the left, as I approach 1, I'm coming to -1. From the right, as I approach x equals 1, I am at 2. So at -1 and 2, that means not the same answers. Now let's try the limit as x approaches -1. Again, they're not saying left or right, so I just have to automatically do both and see if they match. Coming from the left, as I approach -1, I'm definitely approaching, and in fact, I actually hit -3. Coming from the right side and approaching x equals -1, I'm also approaching -3. So if you're approaching the same number from the left and right, even if there was an open circle there, it wouldn't matter. My answer would be -3. So hopefully those are enough examples to give you an idea, and I'm going to make another video that'll help you with the algebraic way to find limits and to find the limits at infinity. Thank you.